Good evening, everyone. Next on our list is going to be Quicksort. So Quicksort is it's an algorithm that holds a special place in my heart, not because I like it, but because I believe that it is evil. It has taken me a couple of years to fully understand it and be able to teach it consistently, and that was about 5 minutes ago that I learned it. Every semester I go and reteach myself and it sticks for about 5 minutes, but I think this time it's actually sticking, which is fantastic. So, the version of Quicksort that we teach in class is Hoare's algorithm. We are going to ignore that for now. Hoare's algorithm, which is a really weird way of saying we pick this partition, whatever the zeroth element is in our array. So, two things that I want you to take away from Quicksort to be able to identify it. We use a partition and divide and conquer to solve the sorting conquer to divide the sorting problem. So what this means is we are going to break it up into smaller pieces and solve those small parts. So, starting on Quicksort, there are two rules that we are looking for in our main loop. The first one is we want to find a number on the left. So, number on left that is greater than whatever our partition is, in this case 1. And we want to find a number on right that is smaller than our partition. So, what you want to do is make up a sort of imaginary left and right pointer variable, whatever you want to say. And we are going to walk these in. Our stopping point, or our base case for this, is when the right side is less than the left. We know that, hey, we have gone past what we can. So, let's go ahead and erase these so we can get started. And I'm going to start on the left side, just for kicks and giggles. I'm going to check, is 0 smaller than 1? It is, so it's fine there. So 0 is smaller than 1, and so we can walk left down. We find that 4 is greater than 1, and we're like, hey, this is a stopping point for now. Let's go ahead and work our way in from the other side. And our goal on this right side is to find a number that is smaller than 1. So we walk R down, we say 3 is larger than 1. Walk it down, we say 5 is larger than 1. We walk it down, we say 4 is larger than 1. And we walk it down, and we say, hey, 0 is smaller than 1. I didn't realize I was covering those numbers. I apologize. There we go. Let me zoom out. So, at this point, we're going to shift into quote-unquote work mode. So shift to work. We have found a left side and a right side. Now, the downside is that our left is at index 2, so L is equal to, I'll do 2 and put I right there. And our right is equal to 1I. So, we don't end up doing any work here. What we do instead, or what we have found instead, is where our 1 is supposed to go. So, wherever R ends up being, whenever we end, so R is right here, so R and L, scribble these out so you don't get confused. R is the position that we want to put 1. So we're going to swap these two. So, rewriting the array, Can I scroll down pretty please? We get 1, 0. I think it's what? 4, 5, 3, 6. Sweet. I forgot to swap them. Oopsie daisy. Can't help being a Gemini. So 0, 1. What we found off of that is 1 is in its absolute spot. So absolute spot. We know that it belongs in this spot. This is its spot designated for it because it is the second element here. Now, this is the only absolute that we know right now. We could have 100 elements before it, it could have 100 elements after it, but we know for a fact that 1 belongs right here. So, since we know that it belongs there, we now have 2 separate sides we need to work with. In this case, we have the side containing 0. Believe it or not, it goes there. We're going to skip that part. And we have this side containing 4, 5, 3, and 6. So, I'm going to go ahead and circle this just because we know 0 goes there. And we repeat the quicksort algorithm on this chunk of 4. So we select the first element to be the partition. We get our left and our right set up. And so I want you to recall that we are looking for the position where left is greater than partition and right is smaller than partition. So we start walking. We say 5 is greater than 4. So we have found our left value. So it will be what? Index 0, 1, 2, 3. 3i. And we start walking the right side in. 6 is larger. We walk it down. And we find that 3 is smaller. So R is 4i, or index 4. So we go into shift to work, clean up, whatever you want to say. On the previous run through, right went before left. So the right index was smaller than the left index. I think it was what? Right was index 1 and left was index 2, which means we've gone too far. In this case, we have not gone too far, and we are going to swap left and right. So, redrawing this, we will get 4, 3, 5, 6. And I'm going to redraw our left and right symbols. If I can scoot over a little bit more, I'd be happy. I can't. So, redrawing our left and right symbols, we have left and right. We're going to walk left until we find a new, larger number. And we're going to walk right until we find a new smallest number. Believe it or not, we just swapped these two in this instance. So, since right is smaller than left, we have found where 4 goes. Go ahead and mark this as our partition. So, now that we've found where 4 goes, we get to swap left and 4, or it would be the right value and 4. So swap partition and right. So when we end, R is going to be here, L is going to be there, so we're going to swap 3 and 4. So we're going to have 3, 4, I think it's 5, 6 at this point, which we would go through, double check that all of this is sorted. We also have 0 and 1 to remember. But at that point, we would have found the absolute spot for these two and 4. So we would do it on the left side of 4, so this remaining 3, and the right side. And the 5 and 6, I'm going to save us all the time. This is already sorted. So quicksort is comparatively faster than the other ones that we've covered so far. So bubble, insertion, and selection. So this is faster. Now with that speed increase, it's more complicated to learn and implement. But I believe, what video is it? What video is it? Quick sort in 4 minutes. This is the first video in the 3 years. Why do I have Minecraft on here? In 3 years that have made sense to my brain. So give it a watch. It really helped me figure this out. So I will see you all for merge sort.